All right, so chapter 10 was the final chapter we went over, obviously. And it was just looking at graphs to determine whether there was a linear relationship between the two variables or not. And then how do we quantify the strength of that relationship? And also how do we make predictions? So the first thing you probably need to know is how do you tell whether there is a strong linear pattern, positive or negative, based on a scatter plot? So that just means if I give you a plot, you should be able to determine whether like a positive, strong linear relationship, strong negative, stuff like that. Or if there's no relationship at all. Know how to determine what is the independent, dependent variable. If I give you a graph, you can just look at the axes and see what axis is which, and the x-axis is the independent variable, the y-axis is the dependent variable. Like I said there, the independent one is the one that is being changed to see how it affects the dependent variable, the result variable of the response. What is the population correlation coefficient and what values can it take on? So what does the population correlation coefficient actually do? So it measures the strength of the linear relationship between the two quantitative variables, x and y. And the range of the values it can take on are between, that should be -1 to 1. Dang it, I messed up on that. It should be -1 to 1. It says often we can't find rho, so we estimate it using R. That's just saying we use a sample to estimate the population parameter. How to use the correlation coefficient to calculate the coefficient of determination. So the coefficient of determination is something that I didn't talk about. I said watch the video over it since you wanted me to. So it's just R squared. So you just take the correlation coefficient and square it. So if you're squaring something that's in between -1 and 1, obviously the square of it is going to be in between what two numbers? So if I take something negative and square it, it becomes positive, right? So it's going to be positive, and the smallest it can be is 0. Because 0 squared is 0. What else? Oh, the definition of what the coefficient of determination is. Did I not put that there? Oh, wait, did I? There it is at the bottom, never mind. Using the calculator to find the correlation coefficient and coefficient of determination R squared. Y'all know how to do that, right? You just run linreg t-test on x and y. Make sure x and y are in the right columns, or else you may get a different thing for a and b, but r and r squared will stay the same. If you run just linreg on the calc option, it'll only give you the a and b values. It won't tell you the actual r and r squared. Then how to interpret r and r squared. So we talked about how close it is to -1 or +1. That indicates a strong linear relationship between the two variables. And if it's close to -1, it's a strong negative linear relationship. If it's close to +1, it's a strong positive linear relationship. And then the thing we didn't talk about, R squared represents the percentage of variation in Y explained by the regression line. You want me to explain what that means or not? Okay, it's kind of confusing, but we'll draw it. Oops, I need to know how to draw. So say you have a scatter of points like this. So you fit your regression line somewhere in, let's see if I can draw it a different color. In here. What the? In here. Stupid thing. Why is it not working? Edit. Done. What the? Why is it doing this? I don't know. I'm just on the board. It's not working. Then I'll pin this. Sorry, I don't know why it was doing that. So you have X and Y. You have a scatter plot. Then you have line of best fit, or what we're calling the regression line. And it would be roughly through there somewhere. So what R squared is doing is, so if you don't have this regression line here, the best way to estimate each Y value is by taking the sample mean. So if you do that, it's probably like right in there. So to this line, you can tell that these points are quite far away, right? So this is what we call the total variation. Take the distance each line goes to the sample mean, and then you calculate the square sum of all those. So you take these lengths, you square them, and you add them all up. What R squared does is it takes this distance to the regression line here. And obviously that's much smaller, right? And R squared is the ratio of those two. That's what it means, explained by the regression line. Everyone understand that? The next thing, using the calculator to find the regression line, y prime equals a plus bx. So we just talked about how to do that. Just run ln-reg t-test on x and y. It'll tell you a and b. The last thing, finding the critical R value for testing the hypothesis, rho is not equal 0 versus the two-sided alternative, and how to make the decisions. So we talked about this in chapter 10. So to find the critical R, you look at degrees of freedom is equal to n minus 2, where n is the number of XY pairs. And then you look at the corresponding alpha. So the two alphas it says in the table is 0.01, 0.05. So then based on the value of alpha and the number of ordered pairs, you can find the corresponding critical value. And the decision rule is you reject the null hypothesis if the absolute value of your R is greater than the critical R value. In your homework, it'll have you enter in the critical R values. So I don't like how it does it, but it'll have you put a plus and minus to that number, because technically it's a two-tailed test. So it's looking at the left tail and the right tail. So you need to put the negative and the positive in there. Everyone okay up there? Okay. Well, that was all we went over. Y'all want to go over the practice exam I made or not? Great. Okay, I think this is the one I put up. Let's see if I can hide the answers. Ta-da. Oh my, what in the world did that do? No, it zoomed in too much, that's why. It's the practice exam key, not the exam key. So expect a format like this in the exam. So of course you'll have true, false questions, multiple choice, and then there'll be a couple for your response. So let's look at the first one. Inferential statistics consist of the collection, organization, summarization, and presentation of data. Is that true or false? False, yes. What is that, the definition of? Yeah, descriptive. Quantitative variables are variables that have distinct categories according to some characteristic or attribute. What is that? What is that, the definition of? Qualitative. Sampling error is the difference between the results obtained from a sample and obtained from the population from which the sample was selected. That's true. That's just the definition of sampling error. The median is one of the measures of central tendency. Did someone say true? Yeah. What are the three measures we talk about? Yeah, mean, median, and mode, and one that we often don't talk about is the mid-range. So know about that too. The median is the midpoint of the data set. I don't know whether there were two. Oh, that's the mean, not mean. The mean is the midpoint of the data set. That's false, not all the time, only if it's normally distributed. The sample space, denoted S, is the set of all possible outcomes of a probability experiment. That's true, it's just the definition. The mode is the number that occurs most often in the data set and more than once. True, just the definition. If one event occurring affects the probability of another event occurring, then the two events are said to be independent events. False. It should be does not affect the probability of the other occurring. Then it would be true. Discrete probability distribution consists of the values a random variable can take on and their corresponding probabilities. Someone besides Randall? True, yes. Next one, the variance of a binomial random variable is NP, where N is the number of trials and P is the probability of success. Anyone? It's false. What is NP for a binomial experiment? The mean. Where were we? Here we are. If two events A and B are independent, then the probability of A and B is the probability of A times the probability of B. True. That's just one of the properties. For a normal distribution, the mean, the median, and the mode are all located at the center. True. Be careful. I have been known to put the mean, the median, and the standard deviation or the variance. So if you don't read the problem correctly, you get it wrong. I'm devious sometimes. What else? For a continuous random variable, the probability of any single outcome is equal to 0. True. I explained why that is. The empirical rule states that 95% of the data falls within 2 standard deviations of the mean. True. So know the empirical rule. I forgot to tell you all that. Y'all remember what it is? Within 1 standard deviation, it's 67? 68, okay. Some people use 67, some use 68. Then 95 is within 2, and then 99.7 is within 3. The next one is just the definition of type 2 error, or yeah. Type 2 error occurs when you fail to reject null hypothesis when it's actually false. What in the world was that? I think it was construction, but I'm not for sure. Okay, that's true. If the test is two-tailed with a significance level of alpha, then the critical region will lie on both sides of the distribution. That just means there's going to be 2 areas when which you reject the null hypothesis. What do you think? It's true. That's why it's called two-tailed. Okay, so the true and false questions aren't meant to be hard. They're just meant to test you. The sample correlation coefficient is a unitless measure. That's true. That's one of the properties of it. The closer to 0, the correlation, the closer to 1, the correlation coefficient is, the weaker the linear relationship between the 2 quantitative variables. False. Should be true. Wait, no. Closer to 0, my bad. The coefficient of non-determination R squared is the percentage of variation in Y explained by the regression line. No. Coefficient of non-determination. It's the percentage of variation not explained by the regression line. It's just the opposite. That's something I didn't go over in class, but it was on the video. So if I give you a value of R and I ask you for the coefficient of non-determination, expect to have one of the answers be r squared and be 1 minus r squared. And then there will be 2 random numbers. Please don't pick the random numbers. Okay, next one. If I divide the population of Oklahoma, wait, was it the last one? Yes, it is. Wait, no. Number 20, if r squared equals 1, then there exists a strong linear relationship between the 2 quantitative variables. And we got to guess. That's true. If r squared is equal to 1, then what is r equal to? 1 and what else? Yeah, 1 or negative 1. So therefore, if it's 1 or negative 1, obviously, it's a perfect linear relationship between the 2. This question has been on a lot of my exams. If I divide the population of Oklahoma State undergraduates into those into Greek organizations and those not in Greek organizations, take surveys from both groups and want to compare the groups, what type of sample was drawn? Stratified. I divided the population of interest, Oklahoma State undergraduates, into 2 different groups. One were in, I think Greek organizations means fraternities or sororities. And then from each of those corresponding groups, I took a random sample, stratified. Next one. Why am I not covering the rest of them? Power couple John and Ann want to involve their fans in naming their 3rd child. They decided to ask about baby names by taking a list of their Twitter followers, and contacting every 1,000th name on the list. What type of sample is this? Yeah, systematic, every Kth member, so it's systematic. I don't know who in the world would do that. That's just weird. You just post a poll. Hey, here's the one I made about myself. In the survey, John and Ann would like to question about the name Joshua. Their statistical consultant suggests who in the world has a statistical consultant. The following question: they strongly approve, have no opinion, disapprove, or strongly disapprove of the name Joshua. What type of response is it? Yeah, ordinal. There's order to them. So if you say strongly disapprove, that's not nice. Next, professors at OSU were asked what their yearly salary is, and the response was recorded. What type of variable is this? That one's kind of tricky. No. It's one of the 2 numerical ones. So it's either interval or ratio. Which one do you think it is? Ratio, yes, you can compare the salaries of 2 professors at OSU. So if you can compare the 2, then it's ratio. Which of the following variables is qualitative? So basically, what is a category? Yep, hair color. Okay, to save money, say administration decided to ask random individuals at OSU what their major is. What type of sample would this be considered? What do you think? Yeah, simple random sample. This one goes back to the class width. If a frequency table will have 6 classes and the data has a minimum value of 15 and a maximum of 49, what is the smallest possible integer for the class width? So remember, the class width was found by the range over the total number of classes, and the range is what? 49 minus 15, which is what? 34. 34 divided by 6 is what? I think it's like 5.66666. So therefore, it would be what? Rounded up to be 6. What is the shape of the distribution below? Left skewed. The tail is to the left, therefore it is left skewed. If I give you a question like that on the exam, please get it right. It's free points. If the 5-number summary for the data set is blank, what is the 3rd quartile? Wait, no. What is the median? Yeah, 23. It's just the number in the middle. So remember, the 5-number summary goes the minimum, Q1, the median, the third quartile, then the maximum. In the data set 1, 2, 3, 4, 5, what is the mean? Oh, I missed one. In the data set, blah, 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 what is the third quartile? So it has an odd number of numbers, so you can find the middlemost one and then look at the data values that fall above it. And if you do that, there's 4 data values that fall above it. I think it's 8, 9, 13, and 16. So you average the 2 most middle, which are 9 and 13, and you get 11. Or you can just plug it in the calculator and run one variable statistics on it, and it'll tell you. In the next one, in the data set 1, 2, 3, 4, 5, what is the mean? Yeah, 1, 2, 3, 4, 5. They add up to give you 15 divided by 5 is 3. If the standard deviation of a sample of 26 is 2.5, what is the variance? In this case, I give you S or S squared. I give you S. You want S squared, right? So you take S, which is 2.5, and you square it. So in that case, it'd be B, 6.25. Which of the following is not in the 5-number summary? The answer is right there. The mean. So remember, it's the minimum, the first quartile, the medium, the third quartile, and then the maximum. So the mean is not in there. Holy cow, there's a lot of these. Given the probability of it raining today is 0.32, what is the probability that it won't rain? Yeah, just 1 minus that. What is the probability of getting an even number when a fair die is rolled? So how many odd numbers are there or even numbers are there on a die? 3. And how many total numbers are there? 6. 3 over 6 is 0.5. Know how to do this next one. If the probability of Z being less than some Z score is equal to 0.8485, what is the corresponding Z value? Yeah, so you just look for 0.8485 inside the table because it's already given you the area to the left, and it should be, I can't remember if it's B or A. I think it's B. No, it's A, never mind, 1.03. What if I said if the probability of Z being greater than big Z is equal to 0.1515? Anyone know that one? Wait, did I say it should be less than? The probability of Z being less than little z is 0.1515. What answer would that be out of all those? Anyone got an idea? What? Yeah, D, correct. So I'm just saying the area to the left of something is 0.1515. So in this, never mind, don't worry about that. I just confused myself. But D is the correct answer. If a random variable X is normally distributed with mean 10 and standard deviation 2, what is the probability of X being in between 4 and 16? So there's an easy way to do this. Just use the empirical rule. So 4 is how many standard deviations away from the mean? 3. And 16 is how many standard deviations away from the mean? 3. So therefore, you're within 3 standard deviations of the mean. Therefore, 99.7% of the data will be in there. A. So if there's a question like that, use the empirical rule. Otherwise, if you can't remember the empirical rule, use the z-score formula to find the corresponding z-scores, and you will get basically the same thing. Which one next? To construct a 99% confidence interval for the population mean when we know the population standard deviation, what is the critical z value? Does everyone know how to find those? Please tell me you do. We've done it a lot. So it'd be a two-tailed test, basically, kind of like how we did in 8 and 9. So therefore, the area in the left tail is going to be what? Anyone remember? Alpha divided by 2, and what is alpha in this case? Yeah, 0.01. So therefore, 0.01 divided by 2 is what? 0.005. You're looking at the area in the left-hand tail is equal to 0.005. And that'll tell you the negative critical value. The negative critical value ends up being negative 2.580. So therefore the positive is 2.580. As the sample size n decreases, what happens to the standard error of your point estimate? Yeah, increases. This one is just the opposite of what I usually say. So if your denominator is getting smaller and smaller, so for instance, then that number is getting larger and larger. Therefore, the standard error is increasing. What about the margin of error? Would it be the same thing? It would. As long as you keep the confidence level the same, it will still do the same, increase. Classify the hypothesis test as two-tailed, left-tailed, or right-tailed. So I'm just asking, what is the alternative? Blah, blah, blah. A long-distance telephone company was to perform a hypothesis test to determine whether the average duration of long-distance phone calls has decreased from the mean of 7. Yeah, left-tailed. What indicates left-tailed? Decreased. Okay, let's see if I can get this stupid thing to work on the iPad now. Okay. Where did I? There it is. How do I open this? No. When did I give this practice exam? There it is. Sorry, I was trying to find it. My iPad's being a mess. There it goes. We recovered. I don't care. Not now. Okay, we're going to go back to the iPad. That way you don't know the answers already. What is the meeting ID thing? Oh, I don't even need to do that. I'm already in. Got it. Share screen. Start. Okay, why is it taking so long? There it is. Okay. Now we're on to the very bottom part. Why is this not going away? Okay. In Pennsylvania, the average IQ score is 105. The variable is normally distributed with a population standard deviation of 10. A school superintendent claims the students in her school district have a higher IQ than the average. She selects a random sample of 40 students and finds the mean of the test scores as 106.7. Test the claim at alpha is 0.05. So the first part is identify the null and the alternative. So this is just like what we did. What is the null? Yeah, mu equals 105. What is the alternative? Yeah, higher than, so greater than, so A. Okay, what is the corresponding critical value? And I said, note, this is a one-tailed test. What's up? That's if it was two-tailed, it'd be A. B is correct, yes, 1.65. You want me to draw why it is? Great. So you have a one-tailed test and it's right. So therefore the area in the right-hand tail is going to be alpha, which is 0.05. So therefore down here is 0.95. If you look it up in the table, it's going to be, there's one that's 0.9495 and 0.9505. Take the 0.9505. So therefore it ends up being B. Also, I don't give you 1.64, so obviously it's 1.65, so B. Why in the world does it keep going up? If I didn't, yeah, be fine. Because it probably wouldn't affect your overall decision. Compute the corresponding test statistic. So some of you on exam 3 switch the numerator. So remember, calculation is like this. Z-test is equal to the sample mean x bar minus the hypothesized mean divided by sigma over the square root of n. What is x bar in this case? The sample mean. Yeah, 106.7. And the mu naught is 105. So it's 106.7. Oops. Minus 105. Divided by sigma, which is 10. Divided by the square root of 40. And if you do that, what do you get? Anyone? It's B, 1.08. Decide whether to fail to reject or reject null hypothesis. So you compare the critical value to the test statistic. And since it's a right-tailed test, what is the decision rule? Yeah, so reject the null hypothesis if your test statistic is greater than the critical value. So is 1.08 greater than 1.65? No, so therefore fail to reject B. Then the last part, there is enough evidence or not enough evidence to say the mean IQ in her district is greater. Did I not change the number? That should be 105, and there's not enough. Yeah, not sufficient. Does that question look familiar? That was on your exam 3. But it was 104.5 and 107.2. That's why this last part says 104.5. I didn't change it. A study using 2 random samples of 45 people each found that the mean, that the average amount of time for those in the age group of 26 to 35 spent 34.2 hours per week on leisure activities, and those in the age group of 46 to 55 spent 32.5 hours. Assume the population standard deviation for those in the first age group is 4.6, and those in the second age group is 3.8. At alpha is 0.05, can it be concluded there is a significant difference in the average times each group spends on leisure activities? What is the null and the alternative? C is correct. And why is it not equals 0? Yeah, just significant difference. What is the corresponding critical Z value? Randall. Yeah, now it's A. Find the corresponding test statistic. So you may want to remember this formula. Z test is equal to x1 bar minus x2 bar divided by square root. Remember this part, sigma 1 squared over n1 plus sigma 2 squared over n2. In this case, I just gave you sigma 1 and sigma 2, so you need to square them. If you plug all that in, what do you get? Crickets, crickets. C. Close. It's A. Then find the associated p-value. How would you do that? Very good. That's start. And do what? They take 2 times what in the table? Yeah, so you take 2 times the probability of z being less than the negative 1, so less than negative 1.91. I have no idea what that probability is in the table. Does anyone? What's up? Yeah, the answer is C. So this probability here is actually A. So the probability of, gosh dang it. Whoa, what did I do there? Nope, nope. This part here, stop moving. This part here is A, but when you multiply it by 2, it's C. Okay, now compare the p-value to alpha. Is the p-value less than or greater than alpha? Greater than, barely. Therefore, what is your decision? Anyone? Close. Failed to reject. The p-value is greater than alpha, you fail to reject. If it's less than alpha, then you reject. Nope. I would just laugh. Inconclusive, that's just BS too. Oh, where does this come from? Your notes. I just changed the number of absences. The final grades made them up. So a study is conducted to determine the relationship between the number of absences and final grades. The data and the corresponding calculator output are pictured below. Let alpha equal 0.01. So what is the null and alternative hypothesis for testing the significance of the linear relationship? What? You say B? That's correct. We're just looking at rho equals 0 indicates there's no linear relationship. Rho does not equal 0 indicates there's a linear relationship. So it is B. If you put C, that's not right. It's the reverse. What is the critical R value? And I tell you alpha is 0.01. So intersect alpha is 0.01 with what degrees of freedom? 1, 2, 3, 4, 5. Yes. And if you do that, you get what? Yeah, the last one, D. Gosh dang, why does it keep doing this? Then decide whether you reject or fail to reject the null hypothesis that rho equals 0. So I give you the value of the sample correlation coefficient in the calculator output. Take the absolute value of that. What do you get? It's not a trick question. Just take the negative off. 0.9747. Is 0.9747 greater than 0.875? Yes. Therefore, you what? Yes. There is a significant linear relationship or not a significant linear relationship between the two. Significant and why? Because you rejected the null hypothesis that rho is equal to 0 in favor of the alternative that rho does not equal 0. What is the equation of the fitted regression line? A is, I'm pretty sure it's correct. Let me check. I haven't looked at the output. It is A, yes. I give you A and B right there. That's easy as that. If I give you something like this on the exam, I don't know if I'm going to give you the calculator output or not. I wasn't nice last semester and made them do it. I think, I can't remember. We'll see. What is the predicted final grade with a student with 4 absences? What do you do? Yes, very good. Plug in X is 4, and what do you get? I don't know what the answer is. Don't y'all love my sarcasm today? Reagan, give me the correct answer. What is it? What? What time is it? Great. Yeah, it's B. Okay, are there any questions over any of that stuff? Okay, great. So we're going to go over one final thing. How do you calculate a residual? This will show how many people have been paying attention. It's the actual Y value minus the predicted. So actual Y value minus the predicted Y value. So in the data set, you'll be given the actual Y value, right? You have corresponding final grade. And then based on the equation, in this part right here, for a given number of absences, you can compute the predicted final grade. So say, for instance, I want to find the residual corresponding to, let's go with 6. So for x equals 6, our actual Y is 74. So our actual Y, so let's say why is it not drawing? At x equals 6, the actual Y is 74. And the predicted Y, let's find that real quick. So it'd be 97.6573 minus 6 times whatever that is, 5.0839. Someone tell me what that is, because I have no idea. I just made it up at the top of my head. $67.1539. So all you do is plug this in for the predicted Y value. It did this on the homework, didn't it? Or did it not? I can't remember. It did last year, but she may have took it out. 67.1537. What is the difference between those two? $7.8463. Cool. Okay. Now let's see if you can figure this out. Was the value predicted using the equation an overestimate or an underestimate? Under. This value here is less than the actual value it got, right? So it's an underestimate. If it was overestimate, this difference would be negative. Let's see what else. That was all for the practice final that I had. I'm debating. Originally, it was just like this, but I don't know. I printed off all 105 of them, and I noticed there was a mistake on them. So I was like, oops. What in the world are they doing? Yeah, it sounds like they're sawing. I don't know. Okay. How many of you haven't done the survey? You can go and do the survey now. And then upload your response. Or upload whatever it is, the picture. I can see the percentage of you that have, but I can't see what you said yet. Let's see, my.okstate.edu. Oops, camera's covered. Please don't make me. You better not rate me bad. I'm trying to average a 4.8 here. I average a 4.7. I better get better. Why 4.8? Because it's greater than 4.7. That's what I've got like every semester. Excellent. You all had a fun time in here for the people that came. No idea. Probably a lot. Statistically, probably 65% of this class. If you want a confidence interval, it's probably between 50 to 70. So it shows that 64.15% of you have responded. It's pretty good. Last semester it was like 95. It's because my class was half this size. Yeah, I had 50 something last semester. I don't know why everyone enrolled in my class this semester. I will over the summer, but as of right now, I'm assigned to something else. What? Yeah, statistical literacy, stat 1013. Y'all want to go over this other practice exam that I have that I didn't post? It's other stuff that y'all could see. I don't care. Great. I'll just show it on the camera. Oh, I got to turn it on first. Lumens. There we go. Okay. A part of a population is called a what? Sample. B. GPA is a what type of variable? This one's kind of tricky. Continuous, correct. Number of students in this class is what? Discrete, I can count you. Gender is a what? Nominal. What? Okay, good, good. Making sure. Monthly salary is what? What do you think? I had to look this one up to make sure it was right. Anyone got an idea? Yeah, it's continuous. Yeah. In a blank sample, every kth member of the population is selected. What is it? Systematic, very good. From the graph, the distribution is what? Symmetric, very good. Which the following is a measure of variation? Range, very good. The rest of them are measures of position and measures of central tendency. A value computed using data values from a sample is called a what? What's the title of this class? Statistics. The value in a data set that occurs the most is called the what? Mode. A data set that has two modes is called what? Bimodal. What if it has more than two? Multimodal. Modal. S squared denotes the what? Sample variance. Which the following is not in the 5-number summary? That's an exact question from the other one. The mean. Let's see. That's basically the same. The set of all possible outcomes of a probability experiment is called the what? Sample space. Given the probability that it rains is 0.75, what is the probability it doesn't rain? 0.25. So if that's been on 2 consecutive practice exams, you may see something like that on the exam. On the menu, there are 3 appetizers, 4 entrees, and 2 sides. How many possible meals can be made? 24 is multiply. The sum of the probabilities in a discrete probability distribution has to equal what? 1. If you give me 2, that's kind of funny. Or if you give me -1, that's kind of funny. The normal curve is what? Bimodal, unimodal, trimodal, polymodal. Anyone got an idea? So there's one peak, right? Unimodal. There we go. The other 2 are just 2, 3, and 4. Next. Empirically, 95% of the data values fall within how many standard deviations of the mean? 2, correct. Find the probability of z being greater than -2.34. Okay, so your guess was pretty good. I can't remember which one it is. Let's see. It is B. So you're looking at the area to the right of a negative z-score, correct? So obviously it's going to be quite large. If I would have said the probability of z being less than negative 2.34, it would have been A. What statistic best estimates mu? What do you think? What have we been using to estimate the population mean the entire course? Anyone? There we go. Yes, X bar. So if your distribution is not normal, which one do you think is better? Anyone got a guess? The only other one on here that's a measure of, did I put two? No, it says alpha. It's a sample median. Find the value of alpha that corresponds to a level of confidence of 99%. 0.01. How do you find that? Yeah, 1 minus 0.99. Find a T alpha over 2 for a 99% confidence interval for the mean where the sample size is 20. So you need to use the degrees of freedom is equal to what in this case? 19, correct? And then intersect that with a 99% confidence level and you get what? Anyway, B. A graph used to check the relationship between two quantitative variables is called a what? What did we do in chapter 10? Scatter plot. A positive relationship between two variables means as x increases, y what? Increases. That was actually a homework question, I'm pretty sure. The coefficient of determination is a number between what and what? There you go, 0 and 1. 1 and 1, that's just one number. Given R is 0.73, find the coefficient of non-determination. So what am I asking for here? Yeah, 1 minus R squared. If you do that, you get what? I can't remember which one it is. I think I know what it is though. Anyone got an idea? If you do R squared, you get D. If you do 1 minus R squared, you get A, which is the correct answer. I think this is pretty much the final I gave last semester. I think it is. I don't know. A real estate agent compares the prices of homes in two municipalities in a certain location. Does that just mean cities? I have no idea either. The results of the study are shown. Is there enough evidence to reject the claim that the average cost of a home in both locations is the same? Last semester, I just put city A was Stillwater and city B was Norman. So what do? First, state the null and the alternative. What is the null? If I give you something less like this on the exam, please don't involve the statistics in any way in the null and alternative. So the null is the two means are the same for the houses, right? How do you write that? Yeah, or another way you could say is, yep. And what is the alternative in this case? Not equal. It just says there's enough evidence to reject the claim. So it doesn't indicate whether it's going to be greater than or less than. Calculate the test statistic. How would you do that? X1 bar minus X2 bar divided by the square root of sigma 1 squared over N1 plus sigma 2 squared over N2. If you do that, you get what? I know what the answer is. I just want one of you to do it. Can you write the formula? Yes, I can. So this is a z-test, so z-test equals x1 bar minus x2 bar divided by the square root of sigma 1 squared over n1 plus sigma 2 squared over n2. That's the formula. So if you plug in the numbers, what do you get? Yep, negative 2.62. I just ran out of 2 decimal places. Okay, now the next part. What are the critical values that define the rejection region? So it's a two-tailed test, so there's going to be how many critical values? 2. There's going to be positive and a negative. And you're looking at the area in the left-hand tail to find the negative critical value is what? Anyone? 0.005, and if you do that, the critical value you get is negative 2.58. So both of them are positive and negative 2.58. Then based on your calculations, what is your decision? Reject because, you can say because the z-test statistic is less than the negative critical value, or the absolute value of this is greater than the positive critical value. So is there enough evidence to conclude the average cost of a home in both locations is different? Yes, because you rejected. Okay, next. A magazine article reported that at most 13% of adults buy takeout food every day. It's probably higher than that. A fast food restaurant owner surveyed 220 customers and found that 33 of them purchased takeout food every day. At alpha is 0.05. Is there evidence to believe the article's claim? So state the null and the alternative. What is the null? Yep. So be careful. Some of you on the exam wrote, or on exam 3, wrote mu equals 0.13. It should be p because you're dealing with the population proportion. And what is the alternative? Anyone got a guess? It doesn't indicate whether it's going to be less than or greater than, right? So it's not equal to. Not equal to 0.13. Then calculate the test statistics. So this will be a z-test statistic. And how do you find it? Divided by the square root of p naught 1 minus p naught over n. What is p hat in this case? Yep, very good. So all you do is plug those in. You get 33 divided by 220 minus 0.13 divided by square root of 0.13 times 1 minus 0.13 over 220. And what do you get? The 2 decimals. Yeah, 0.88. Then using your test statistic in part B, find the p-value. So since the two-tailed test, you're going to take what area and multiply it by 2. P-value is 2 times the probability of z being something something. Anyone got an idea? Instead, if you're looking at the p-value, look at 2 times the probability of z being less than the negative test statistic. So less than or equal to negative 0.88. Do that, you get 2 times what? Be 2 times 0.1894, which equals 0.3788. Now that you have the p-value, you can compare it to alpha. And obviously, this is much larger than alpha. So therefore, what is your decision? Fail to reject. And is there enough evidence to believe the article's claim? Wait, which one is it? I think it's actually yes. Because the claim is that p is equal to 0.13. Pretty sure it's yes. Because I think I did that on the exam last semester and I tricked him. I don't know. Don't worry about that one. That won't be on there. Okay, this one here, I wasn't as nice to give you the calculator output, so you had to enter it in. So first you need to identify what is x and what is y. Yep, and y is length of service. So all you do is enter in these into a list, this in L1, this in L2. Okay, well, we need to first do this. So independent, I'm just going to do age. So that's that. Dependent is a length of service. I don't even know what length of service it is. I assume it's in the military. Calculate the correlation coefficient. So I guess I'll show you all how to do that in case. Let me make sure there's nothing in here that y'all don't need to see. Clear list. L1. How in the world did you say you clear all the list at once? Oh. Okay, edit. So in the first column, we're going to put age. I don't know why it's in decimals of years. That's just a weird age. 24.9. That's pretty close to my age. 25.6, 26.1, 27.3, and 27. 66.5, 70, 74.8, 89.6, and 82.6. Make sure you enter them in paired correctly. So once you have all that in, hit second mode. It'll take you back to the home screen. Then go into stat test, linreg t-test, option F. Hopefully you don't get an F on the final. Tell it what you want your X and Y to be. So X was in L1, Y was in L2. And the alternative is always, oopsies, gosh dang it, not equal 0. Then hit calculate. So the correlation coefficient in here is what number? R, very good. So that means we have R is equal to, oh my Lord, that tasted gross, 0.9784. What does this correlation coefficient tell us about the linear relationship between age and length of service? Strong positive linear relationship. Golly, my handwriting is a mess, but who cares? Strong positive linear. Calculate the coefficient of determination and interpret your answer. It's just given right there. So what is the coefficient of determination? Yeah, 0.9573. 0.9573. And interpreting it, we have the percentage, or you can say, let's say it this way, the percentage of variation in length of service. How did I write it? (95.7% of the total variation in length of service is explained by the regression line. There you go. Then it asks you to test the significance of the correlation coefficient using the steps. So it's to state the null and the alternative, it's still the same. Rho is equal 0 versus rho does not equal 0. We're not going to go over the last one on here, I don't think. Okay, what critical value should be used? And it says use alpha is 0.05. So the degrees of freedom you use is what? There was 5 pairs, minus 2 is 3. So use the degrees of freedom of 3, and alpha is 0.05, and you get what critical R value? It's right there, 0.878. So therefore, is there a significant linear relationship between age and the length of service? Yes, there is. Therefore, you need to write out the fitted regression line using the calculator. So all you do is look at what A and B are, A and B, and you write it out. Usually do it to 3 decimal places. If a service person is 26.6 years old, predict the time that the person will serve. So all you do is plug in x 26.6 into the equation, and you get 80.607. Is everyone okay with that? Great. Okay, this last one here. The National Novel Writing Association states the average novel is at least 50,000 words. That's a lot of words. A particular ambitious writing club at a college preparatory high school had randomly selected members with works of the following lengths. At alpha is 0.1, is there enough evidence to conclude the mean length is greater than 50,000 words? Assume the population is normally distributed. It says using the traditional method, so that just means using the critical value method. State the null and the alternative. The null is that mu is equal to 50,000, and the alternative is indicated right here. Is there enough evidence to conclude the mean length is greater? So the alternative is greater than 50,000. Then you calculate the test statistics. So what you'd have to do in this case is calculate what X bar and S is. So you'd plug these into the calculator, find X bar and SX, and round into 3 decimal places. So if you do that, you get this average and the standard deviation. And if you calculate the test statistic, you get 4.481, which is quite large. And then what critical values define the rejection region? So it's just a what-tailed test. Right-tailed, so there's only going to be one critical value, and it will be what? Positive. So all you do is look for alpha is 0.01, one-tailed, and intersect it with 5 degrees of freedom, and you get 3.365. Then, based on your calculations, what decision do you make? So since this test statistic is greater than the critical value, therefore you reject the null hypothesis. Thus, there is sufficient evidence to conclude the mean length is greater than 50,000 words. Okay, and that was all. All right, well, thanks for your patience this semester. Hopefully you didn't have too bad of a time. Don't forget your final exam is at 10 o'clock on Tuesday. It'll be from 10 to 11:50. It probably won't take you the whole entire time to take it. Yeah, I know. Also, if you want your exams, any of them, come to my office. They're all in there.